We're going to look at quantitative reasoning to solve prediction and comparison of problems involving ratios and rates. Quantitative is just a value. We're looking for a difference in values of ratios and rates to make some predictions and comparisons. Remember, ratios are comparing the same things like pencils to pencils, whereas rates would be different units like miles to hours. Let's take a look at this next problem. There are 63 dogs at a dog show. The ratio of the number of dogs to the number of small dogs is 4:3. How many dogs at the dog show are small dogs? And we see we have some answer choices, 36, 21, 9, and 27. So as I approach this problem, I notice there's lots of words, there's some numbers. The first thing I need to think about is, what is it I need to find? So I'm going to go back to my question and reread. How many dogs at the dog show are small dogs? I need to find the number of small dogs at the dog show. And they've given us a ratio for large to small, and they've given us this number of dogs. So let's think about how we're going to use that. What do I know? I know that there's 63 dogs at a dog show. And if I'm talking about 63 dogs at the show, that must be the total dogs there. I also know that for every 4 large dogs, there are 3 small dogs. So my ratio is 4:3 for large to small. Now these seem like part of the total dogs that are there, because some of these 63 dogs are large and some are small. So we need to figure out this small. We're looking for a part of that total that's at the dog show. So we know that out of the total in this ratio, if there's 4 large dogs and 3 small dogs, we must have 7 dogs as part of that ratio. So 7 would be our total for that ratio. One approach to solving this problem would be building yourself a ratio table. So let's take a look at what that might look like. Here I have my table, and I've set my labels of what I'm dealing with. I have my large dogs, small dogs, and all the dogs that are there. I know that they told me the ratio was 4 large to 3 small, which meant a total of 7 dogs. Now I could start with thinking, well, I could double these and go times 2, which would give me 8 dogs, 6 dogs, and 14 dogs. But 14 isn't getting me close to 63, so I have to keep going. So if I try to go here, I'm thinking times 3, I get 12, 9, and a total of 21. I'm still not there yet. I could keep on and go times 4 and get 16, 12, but that's only 28. But maybe I recognize that this total 7, there's a relationship of 7 to 63. What can you multiply by 7 to get 63? That's right, 9. If I multiply and jump from 7 all the way to 63, I would have to multiply by 9, which would then give me 36 and 27. But we're not done, because do we know which one of those numbers represents the number of small dogs at the show? So going back and thinking about that question, we just said the number of small dogs. So I don't want to write 36 as an answer, because that's the number of large dogs. I need to go where the small number of dogs is, and I see that I had 27. So our correct answer choice here is going to be 27. Have you thought about approaching this problem in a different way? Let's take a look at another way. You could also set up a proportion to solve this problem. So just like before, we knew we had a total of 63 dogs, 4 large dogs, and 3 small dogs. So we can set up a proportion, and remember we want to set our labels. So I'm going to compare the small dogs to the total dogs, because that's information I have. Because we knew that with 4:3, we had a total of 7 dogs, and our number of small dogs was 3. So when I add that, 3 to my ratio here, 3 to 7. So 3 small dogs to 7 total dogs, compared to 63 total dogs, and I'm looking for that unknown small dogs. So again, looking to see if there's a relationship between 3 and 7 or 7 to 63. And I remember that 7 times 9 is 63. So I have a scale factor of 9 that's going to get me to 63, which means I can apply that because it's a proportion to the 3. 3 times 9 is 27. So that's another way that you could solve this problem.